In this short segment of lecture, I just want to tell you something about the experience that you guys learned on using deep network, convolutional neural network to learn and train about an object. So there are some example code that we showed about to train a face detector. There's also a demo that we showed about running this face detector. Now, I wanted you to look at the data. Mainly with the deep networks, what happens is that you're gonna find a training set, a test set. You're gonna train on these images, and you're gonna most probably do pretty well if you set up your models well. You're gonna do very well on training and probably testing. But sometimes you might not lose the generality in real life. So what's really going on there? Well, first of all, the generality of your test set might not be as big as you want it. It might not be as big as the real life experiments. Also, you know, if you're training a face detector, remember that you train a face detector in an image, and your face could be really small, or it could be very big, and it could have different illumination environment, different backgrounds. It could be very washed out by the background, or it could be extremely clear because the background is shielded. So look at the changes in illumination that occur around my face, even as the camera right now is adapting to light. So all of this condition, although the complex should take care of it, should probably be in your data set, the training and testing data set. Also, one thing is, when you train for a face detector, we had 32 by 32 input. We generally don't want to recognize 32 by 32 input because it might be that you only recognize faces that are really tiny, so only about this size. So if the face is further away, or if the face is much closer away, you might not recognize it. For that, we use a pyramid, and we discussed it in convolutional and deep network lecture by Isago and by myself. That a great trick is to use a pyramid. So not only take a small input, but also downsample a bigger input and an even bigger input and an even bigger input. Downsample them all so that they can be processed by this 32 by 32 network that you train. But ultimately, there's one more thing that you have to pay attention to, is look at the data you collected. As a human, local contrast normalize these images and take a look at your input images, this 32 by 32. If, for example, you're trying to train for a hand, 32 by 32 pixel might not be enough. It might be hard for you to see that there's actually a hand in those images. If the task is quite hard for you with billions of neurons, it might be maybe too hard or impossible for a small network with the thousands or just a few million neurons. So make sure that you have in your image that you have enough detail to capture all the content you want. If not, resize it, make the image bigger, add another layer, and so forth. Ultimately, though, the last trick that I wanted to tell you is that unfortunately there's always quite a big difference between the testing set performance and what you get in real life. Is if you put this on a demo, in a demonstration, an online demonstration with your computer, you will always get false positive on background like that, or on a background that has a lot of intricate pattern, like for example if you wear a shirt with a square pattern that is very tiny and a lot of colors. It happens. It means that your network is finding the features that thought were a face in those things. So the only way to get around that is to add more context. For example, train a network that is multi-scale, that looks at a small patch, a larger patch that is downsized, and an even larger patch that is downsized. It looks at them all together. So if there's a pattern in one of these in one of these scales, it might not necessarily focus just on that pattern, but it will look at the pattern in different scales and figure out the global ensemble of features that you actually need to recognize. So these are just a few tips that I wanted to mention, because some of the students which I interacted with had a problem, for example, training a hand detector with 32 by 32. Partly, and if you train hand detector and the hand is up like this, it might be fairly easy. But if you're trying to hand detector when the hand is like this, or when the hand is like this, on a 32 by 32 image, it's almost impossible to figure out that that's a hand. There's just not enough features there in the image that distinguish this thing from a ball or from a group or something. So look at your image, look at your data. If the task is too hard for you, it will most probably be close to impossible for your computer or your little program, unless you scale up very well, but we're not quite there yet. We'll probably be able to do some of this at the end of this course.